Bueno, buenas tardes, repito. Quiero dar las gracias a todos los asistentes y sobre todo a los que han tenido cierta celeridad a la hora de comer y han llegado aquí casi en hora. Aunque no esté toda la gente, las necesidades de organización nos obligan a comenzar ya. Yo estoy aquí en representación del Departamento de Urbanística del Territorio. En estos momentos ocupo la plaza de director de departamento y como tal lo que quiero hacer es reconocer el esfuerzo al grupo de investigación que está realizando este proyecto I+D+I, que este es su primer año y esta es una acción complementaria que tiene por objeto difundir los primeros resultados de su trabajo y dar comienzo o presentar lo que puede ser el desarrollo futuro. Es un proyecto de investigación, yo creo que sustancial o crucial en un momento en el que los problemas ecológicos de nuestros territorios, nuestras ciudades van creciendo, en el que pese a lo que podría parecer las tendencias a la destrucción de los ecosistemas y sobre todo a la dependencia de productos importados en la alimentación cada día hacen mayor a mayor. En el caso de la Comunidad de Madrid, el territorio no urbanizable que podía ser dedicado a la obtención de alimentos dentro de una estructura o un cuidado dentro de una matriz ecológica, en estos momentos tiene una agresión que sería una ley que va a permitir construir viviendas en cualquier espacio, en parcelas de 6 hectáreas y llegando a tener hasta 900 metros cuadrados cada una de ellas, ¿no? Parece que en un momento de crisis debería de haber sido el momento de hacer cuentas, ver con lo que uno dispone y prepararse para un viaje que es la necesaria readecuación del modelo de producción y consumo a un mundo sobreocupado, un mundo en el que los combustibles fósiles y las fuentes de estos empiezan a escasear. Por tanto, nos obliga a una cierta austeridad, a un cierto control de ellos. Pues pese a lo que pudiese parecer, o todo el optimismo que pudiésemos haber tenido de que eso se iba a producir, esto no es evidente, sino que se produce lo contrario, ¿no? Las administraciones públicas, el capital, incluso una opinión pública que todavía es incapaz de comprender la complejidad de nuestros ecosistemas, piensa que no pasa nada por ocupar esos espacios y que estos espacios van a ser siempre recuperables. Yo creo que uno de los objetivos de este seminario y el grupo de investigación es poner en valor tanto la necesidad de mantener espacios productivos, ecológicos, agrarios, basados en una agricultura, entiendo, que sometida a los ciclos naturales frente a la agricultura clínica o intensiva, pero también que estos territorios son de una gran fragilidad, que no es cierto que se puedan recuperar fácilmente, que no es cierto que su utilización sea posible para cualquier uso y que cualquier día podamos volver a cultivarlos, que nos queda poco espacio agrícola, que nos queda poco espacio natural y que el poco que queda tiene que ser valorado tal y como merece. En ese sentido, esta mañana ha habido una serie de sesiones dedicadas a los aspectos básicos de lo que se está haciendo en I+D y dentro de los objetivos del grupo de investigación que tienen su aplicación en esta acción complementaria para difusión y discusión, hoy contamos con la presencia de 3 expertos que van a ampliar las dimensiones del problema o la manera de enfrentarnos a ellos. Tenemos al profesor Meyer de la Universidad de Leipzig, que es geógrafo y experto en los servicios de los ecosistemas y en el establecimiento de sistemas de evaluación y de seguimiento de su valor. Marta Peresova, de la Universidad de Wageningen, que es ingeniera agrónoma y especialista en participación. Y, por último, el profesor Andrea Caroli, del Politécnico de Milán, que es experto en la proyectación ecológica y ha trabajado largamente en el Parque Agrícola de Milán. Yo no quiero ocupar más tiempo porque lo importante es dar paso a nuestros amigos que se han tomado el esfuerzo de venir aquí a discutir de ello y luego, en la medida de lo posible, la participación de todos vosotros en un debate que necesariamente acaba a las 6. Muchas gracias y sin más pues daría la palabra al doctor Meyer, que le ruego que se suba, así está aquí con nosotros, y ocupe su sitio. Muchas gracias.
Okay, thank you very much for the kind invitation to this very interesting seminar. I'm Burghard Meyer from University of Leipzig. I'm a geographer, but I have a long time working experience from beginning with physical geography, preparing PhD in cultural geography, working 7 years in applied landscape ecology, followed 5 years in biological conservation, nature conservation sciences, followed by 5 years in spatial planning, and now I'm back in geography at Leipzig University. Okay, my topic strongly belonging to the title and to the whole workshop is including multiple functions into land use decision making. A very wide topic. I will talk about 3 issues. One, first, very shortly, the climate change sensitivity investigation for the usage in spatial planning on the basis of NUTS 3 level. Second, multi-criteria assessment and optimization tool for arable landscapes for the usage in local or regional scale level. And third, regional suburban landscape scenario to show a little bit how to use the landscape functions or ecosystem assessment approach. The background to deal with such complex issues is a territorial agenda of the European Union to 2020. There are several priorities. I skip the priority 6 is managing and connecting ecological landscape and cultural values of regions, including joint risk management as an essential condition for long-term sustainable development. The goal is sustainable development. It's complex. The territorial agenda, spatial planning agenda, of course, focuses on regions. Ecosystem services are capable to break down the values also on the local level, on the level where site matters and where application and changes will normally be done. This is the level of programs normally. Spatial planning and climate change. We focus the challenge that the climate change is predicted, but we do not know exactly which change come up and in which time scale problems should be faced is also not well known. In this context, we applied a study to assess climate change sensitivity for spatial planning for the time horizons of 2030 to 2050 and 2070 to 2100. I'm sorry, this is not working. Is there a mouse to work with the mouse? To show the problems, we use input data of mesoscale modeling and input data of diverse statistical origin for NUTS 3 level. We analyzed the climate change exposure of NUTS 3 regions and, on the other side, the sensitivity against selected indicators essential for spatial planning. On this basis, we analyze regional climate change impacts. And I will directly come to results. It's really no mouse available. You can hear maybe without, but the translation will have problems. The sensitivity assessments focusing on the main problems. Yes, it's. Maybe somebody can help. I don't know the techniques. I'm very sorry. Yes, but I will use this mouse. Then I will always in the right place. Yeah, but run around. If you switch on a mouse, I will do my job best. But in between, I can continue. It's also not switch on. Now? Now? Okay. Okay, so we have indicators essential for spatial planning, scale, longer and more intensive heat waves, increase of heavy rains and flash floods, increase of large river flood events, storms, mass movements, forest fires, destruction of infrastructure, etc. And this this column, we focus next thing, how intensive the impact will be on, for instance, for heat waves. 250 NUTS3 region will focus high risk. In this indicator, the planning should or must react in the future until 2100 for still not working, sorry. In regionalized, you see for each of the single indicators regional clusters, loss of species and biodiversity dispersed in the whole country, storm surges on the coast, groundwater level problems, especially in the south and in the pre-Alps land. If you summarize this to sensitivity map for regional sensitivity, especially the western parts of Germany focusing strong potential impacts of climate change. If this works.
Yes, I know. If you want, I can at least.
Okay, then I tell always next.
That's our technology.
Okay, and the result of the first little bit broken demonstration of climate change impacts, these are the problems planning must focus, and this is also the context an assessment must have in mind for each single ecosystem services. The change in the risk of fulfillment of each ecosystem service. In this context, I will come to the second example of multi-criteria assessment and optimization in arable landscape. The goal here is the development of integrative methods to assess landscape sustainability and model future landscape. Also in the first example you have seen, it's a model background. I have not shown most of the data behind. It's a model of arable landscape where climate regulation, recreation, biodiversity for fauna and flora, and regulation of soil erosion and groundwater and other ecosystem services should be additional functions to the monofunctional use of agricultural production as a general view behind. The land use problems specified in the regions are the basis for the usage of the key models or the key ecosystem services investigated and assessed in a landscape. And in this multiple approach, we have integrated models for species assessment, for landscape experience, cultural aspects, for erosion and water and wind prediction, for the assessment of biotic production capacity, for groundwater production and groundwater regeneration, taking the quality of the water in mind, for runoff regulation, water supply, water self-cleaning, climate amelioration, and at the end, noise protection. This species, red kite, is key species in one of the areas I will show in the following. That means also the integration of species assessment into land use decision making. The land use problem we solved in a very simple way. All the models for each of the single landscape function are simple predictive models. We focus on forest, on grassland, on arable land. We focus on, in this example, of restructuring arable landscape with landscape elements like hedgerows or small field plots, and the whole system was applied together with agrarian cooperative in the landscape. The multi-criteria assessment optimization framework is a grown framework integrating the key aspects in the landscape. We're starting with a goal setting, a goal problem analysis to evaluate the borders of the model applied. On this participatory problem evaluation, the functions assessed will be selected. Then we have the base of geographic information system and assessment rules, assessment of the different problems or ecosystem services applied. Then we have the next tool to optimize land use decision making by producing optimal compromises for land use decision making basing on different goals worked out before together with stakeholders in the landscape. We also applied the framework for landscape planning, the official planning. We applied the second function assessment because planning is normally not based on computer results. It's a result of several decisions, and often the application at the end are not fully fixed to the total picture. The assessment in Mulbo is based on validated assessment methods with long tradition in Germany from basing on Nature Conservation Act. It's taking into account ecological, economic and social functions, taking into account that assessments are results of human demands, and the value dimension is clearly distinct from the analysis part of the system. The results are spatially explicit. All results are based on GIS, and it's overall very flexible to use other methods and other GIS assessment methods to apply. The study example, agrarian landscape for communities, 90% arable land, huge field plots of 100 hectare scale, one field plot. It's a Soviet agriculture applied on the best soils in Germany. Next. Tools for assessment and abiotic of biotic and economic social functions are, you know it, applied on predictive, simple predictive models like the universal soil loss equation applied, and the results are maps of low to extremely increased soil erosion risks related to thresholds taken from planning, from literature, and some of the thresholds have been also formulated in controversial discussions because thresholds are not fully available. The map for soil production, economic function shows larger areas where soil erosion has degraded the high potential of production to medium to low production. This is degradation of one ecosystem service for production of cereals based on soil mapping as a result of the former agricultural use. Landscape optimization's next step is a part of MULBO which spatially integrates spatial functions. Integrates landscape functions. It's a mathematical method based on linear programming and game theory that calculates optimal land use allocation. That means an optimal fulfillment of different goals on landscape development like ecological, social, and economic goals. But you know, you can never optimize all goals in the same time on the same plot. That means that the results are optimal land use compromises between the goals based on the risk assessment maps and goals for landscape development. Functional conflicts will be solved for the whole investigation area. That means the best places will be taken for land use decision. What's necessary? Which goals must be interpreted? A goal is the ecosystem service or landscape function. Which land use types fulfill the goals? In what quality? Here, the assessment is essential. How does the landscape structure contribute to these fulfillments, as in the layers, soil, climate, water, household, territorial, elevation, model, etc. is described. It's a GIS-based models, and you can also apply restrictions and weights, and restrictions can be, for instance, that you only plant something on church land or community-owned land or other lands. Okay, the results for the differentiation, the model assumption that 30% or 15% of new landscape elements are distributed in this agricultural landscapes based on 4 landscape assessment level: wind erosion, water erosion, water production, and arable production results a mixture of smallest geometries basing on the different GIS layers. The mosaic for 30% shows nice landscape not fitting well to the origin of place in the culture. It's a model result to show the capabilities of such compromise optimization approach, where the places, the best places, are found to reduce the risks of the chosen landscape assessment layers. On this basis, we applied formula landscape plan. We applied projects together with the agricultural cooperative to plant hedgerows, to reduce erosion, to change the crop rotation. Very detailed project with results, examples I can show as model outcomes developed together with farmers in the landscape. And for the basis of such new hedgerow field plots are bought together with public money invested for a landscaping group existent in this region. All the methods are described in an interactive user manual. You can find also parts in English translation in www.mulbo.de, as the project was founded by a German foundation to protect nature. Thanks for this. In the last example, we have seen very briefly what we can do when we know the different assessment models, what we know which land use change we like to have, and you have seen that the model can help to produce scenario, or to describe a story, to draw the map for the discussion with the stakeholders, the majors in these four communities belonging to this landscape. We have also heard that without the participatory perspective, the places cannot be found because the goals, how many changes, for instance, should be done, is clearly societal questions when asking what should be the change in the region. And then models and evaluations of ecosystem services can clearly help to find the right places. We have shown earlier comparable sites with major interest or more sensitive sites. And because of that, I will come in third example to other perspective. In this example, I'm looking for best places for suburbanizers to find the best places for housing based on 3 landscape scenarios. The question is where to locate best housing in suburban. Maybe you would like to prevent this, but it's a way to focus on to find the best places. It's a methods development study for applied assessment. It should be integrative for suburbanization problems, and it focuses on 3 suburban scenario stories. The first is taking only economic functions into account, the cheapest place to settle. The next is taking additionally social functions in the story. That means to have a multifunctional landscape. And third, to add ecological functions as it is habitat network integration into account to make the decision which sites are most suitable best into account. So it's again a region in eastern Germany, again huge field plots of 100 hectares, maybe 60, 70 square kilometers. It's a region with morphology, a little bit hilly, but maybe with only 100 meters difference in elevation. Yeah, mostly arable land. Here we ask which suburban indicators can we use for the scenario. We grouped the functions into social functions, ecological functions, and economic functions. The main function and social function is a human ecological function described by the regulation of the traffic noise emission day and night, following the regulation in Germany, the visibility of biotopes and of the relief. We heard before the question what about visibility and the accessibility of recreation areas for in walking distance of new housing. Ecological functions, we have chosen landscape diversity and habitat network integration, and for economic functions we ask for infrastructure development, the cheapest places, and the accessibility. Here we have had the indicators infrastructure development. Accessibility is the next highway by car to go to Leipzig. It's a city 20 kilometers away from the suburban test area of 15 kilometers away. And look the accessibility to local centers by car, by bike, and by pedestrian. We have seen comparable maps today. Traffic noise at the daytime, we used suitable model. You can, for instance, buy models to apply this functional analysis. It's a sound pressure level and the problem of emission reduction, and by looking on the distance from the road, the surface roughness and barriers to prevent. And in the daytime, you have here the main road and a railway and only local country roads in between. The larger parts of the test area are noisy. In the nighttime, when another threshold level is valid, because in the night it must be more calm, the larger areas are noisy and only few remote areas in the land are such calm that you can have a healthy sleep. Same model behind. Visibility of biotopes, we asked about the number of visual connections in form of lookout areas. We analyzed the inside areas and barriers, and everything is based on a digital elevation model. We looked from different points, and the best places to look in and to look out are the most green ones. It's simple, or not very simple GIS work. Visibility of relief is the same idea. It's a lookout areas. Best place to settle is here. You can have a round view, but for other purposes, this place is maybe not very suitable for housing. Okay. Very fast now, accessibility of biotopes around existing settlements, the areas where you can walk around in the half hour, in the evening time after work. These areas are suitable, other areas are not accessible. We have seen comparable in the last presentation. Landscape diversity, because it's intensively used arable landscape. Biodiversity is overall very low, and hedgerows and water courses are assessed high. The edge length as landscape matrix was used to assess each single raster cell. Habitat network is exactly the other way around, that in the arable land, species can better, habitat are better connected than fragmentation to water courses or by roads or of course by settlements will reduce this value, this indicator. Thank you. Infrastructure development, we have chosen a very simple distance rule from the road. The accessibility of local centers are starting by each center of the village. We analyze the road network, availability of private cars, and analyze the speed and how long you need to commute on these places. The accessibility to highway, I talked before, Leipzig is down here, and when you access by this road, these places are the most cheapest and the most fast reachable places. In other areas, you must go the way around. You need up to half an hour to drive to access, and this reduces the suitability of the site for housing from this point of this indicator. Accessibility by bike, starting again in the settlements. It's a longer way can be reached compared to pedestrian, but the pedestrian and bicycle like also reach the railway station to have connection to public transport. The scenario behind is very complex. As I told before, the monofunctional landscape taking only the economic functions in mind, resulting that 34% of the whole area is suitable for housing only by looking on the accessibility of residential area, of next highway, and accessibility of local centers, including the multifunctional perspective, that means the social functions, brought us to result that only 10% are suitable in the best assessment classes, 4 and 5. And if you include the sustainable perspective, by including ecological functions, 7% of the sites are suitable for the housing. In terms of max, the weighting you have here, you have very many sites suitable for housing, mainly belonging to the road connection and the fast accessibility to Leipzig. The multifunctional landscape, as I told, asks the question of the calm settlements, traffic noise by night and day, accessibility for recreation, places, and the visibility areas. Here you see that only some areas belonging to existing villages are best suitable. Areas far away from existing roads are less suitable. Coming to the final scenario, where also the habitat network, and the landscape diversity was integrated. You see that the weighting is always given by number of indicators and the weight indicators down. You can
of course, play a lot around by choosing other ways, brought results to best places usable around existing villages in some areas. Results suitable for local landscape planning and also suitable for investors to find good places where the values are valuable also for a longer time perspective. Okay, the results, as I have for this search example, was the focus was methods development, analysis, producing models based on GIS data, and finding assessments, perspectives, or relationships. It's a spatial explicit modeling of social and economic indicators, and as assessment, we published scenario stories in the background to integrate the different aspects. Future investigation is generally because it belongs to the social perspective. It's the weighting and how to better integrate the interlinkages. A further evaluation and description for the usage in spatial planning is needed, but all of the functions I have shown are based on German legislation like Nature Conservation and Planning Act. It was one example to develop a catalogue of key functions, but the key functions, as I have explained before, are different from one case to next case, and it will be difficult to have the ultimative functions or ecosystem service list applicable in each region of the world, in each climate, etc. We heard the criticism about that earlier. Okay, sum up, linkage to peri-urban problems. We have seen approaches to mirror a little bit multifunctionality and to reach in the direction to sustainability. We focusing today mainly the problem of land in Germany, of land conservation from agriculture to urban, and the problem of land consumption is a key problem, and when landscape functions or ecosystem services are described in the context of land consumption, you can describe statistically which part of your potentials you destroyed by new housing, and it's an economic and ecological and social perspective on that. Decision making belongs to thresholds of systems and preferences of decision makers, and this includes owners, the planning system, and the public-private. And in agriculture, often the farmer is not the owner, and seldomly the discussion will be made with the owners dealing on the long-term perspectives. The approach is an enclosure of economic activities and a way to approach the problem of multifunctionality, that there is not only one key function for in a land, that there are several functions, and that there is a need for society to discuss about the weightings and the value of each of the functions, and in the end, which major functions are accepted. And this is very fruitful for planning discussion. We have seen that modeling and scenario stories are helpful to clarify the integration of multifunctional functions. with stakeholders, and the maps are also statistics behind are a good basis to communicate problems. The tools for predictive modeling are suitable to combine different functions to landscape and land uses as far you know the relationships, and not all of the relationships and also not all thresholds are known. The sets of indicators should become selected and analyzed on the basis of key problem analysis or SWOT analysis in the context of the specific planning regime, culture, and the laws where it should be applied. The overarching problem of multifunctional land uses should become, by the way, systematized, should be broken down into detail. And best here is that the value dimension of this assessment is based on thresholds taken from the resilience perspective, but I think there are only few people having general perspective on resilience. This is a research frontier at the moment going on. Good, I'm coming to the last slide. It's an open discussion in this context because peri-urban means, from my point of view, German point of view, it's a reduce of land consumptions. We should discuss about weightings, interlinkages of land uses and functions or ecosystem services from a system or an integrative perspective. We should analyze the needs of the society by discussing minimal needs taken into the planning, critical thresholds for the indicators and for the whole systems are usable or helpful in the peri-urban context. The analysis of integration into local cultural perspective can be made, because we also heard that landscape should be made from a perception point of view, like European landscape consumption, landscape convention is making, but I am following more the natural science perspective that the indicators in the landscape from social, economic, and ecological perspective can analyze and systematize and structures. But the critical limits, especially for land consumptions or the compaction of urban, are on the one hand the results of the resilience perspective, on the other side are political decisions in which direction to go. For instance, in Germany, 15% of the total land should be useful for nature conservation purposes. In some agricultural lands, this is easy to reach. In other open arable landscapes, this goal will never be reached because the production perspective is such much higher weighted. Economic and social services can be in contrast to ecological services, and there are also internal conflicts between the function fulfillment. For instance, the amount of groundwater recharge must not reflect the quality of the groundwater recharge. Further investigations are needed or useful from my point of view about societal and cultural dynamics in complex and coupled human environmental systems, as the project best doing, and the linkage to European research perspective is made by the European Landscape Convention, the European Spatial Development Perspective, also the approach of ecosystem services can be helpful in environmental impacts assessment, in strategic environmental assessment perspectives, or in the new developments about sustainability. Impact assessment could be helpful to fulfill biodiversity strategy of the European Union, the Flora, Fauna, Habitat Directive, the Water Framework Directive, can also be a part or further development of the TEB approach as the continuous process after the ecosystem assessment, and last but not least can be applied on the practice in landscape planning and regional planning, as I have shown hopefully in some examples. Thank you very much.